So good day, Miss Verdon. We're here. I am here with Sajulla and I'm Arcala to discuss you the image recognition system. So Sajulla is gonna discuss about the train.py. So start Sean.
I'm going to discuss about importing necessary libraries to build and train a convolutional neutral network or CNN. Effectively, we begin by importing essential libraries for machine learning. We have first is OpenCV or known as CV2. Designed for computer vision tasks, this library handles image processing, video analysis, and object detection. It is pivotal for reading, writing, and manipulating image to prepare them for CNN training. Second is NumPy, a core library for numerical computing in Python. It facilitates efficient operation on arrays, linear algebra, and random number generation, making it indispensable for handling image pixel data. Third is TensorFlow and Keras. TensorFlow, an open source framework for numerical computation idea for machine learning and deep learning tasks, offering the tool needed to build and train neural networks. Keras, a high level API integrated with TensorFlow, simplifying the construction, training, and evaluation of neutral works through its user-friendly interface. Fourth is Skikit-learn. Provide tools for processing, model selection, and evaluation. Functions like test, a train test split the data set into training and testing sets, and callback like reduce LR on plate AU. Optimize the learning rate during training to enhance convergence. Those libraries enable the seamless creation and training of a CNN for accurate image classification. Hyperparameters are configurations set before training the influence the learning process and model performance. Key hyperparameter includes train slash dr path to directory containing training image size to which all input image are resized, image channel, number of channel in the input image, first num channel, number of filters in the first convolutional layer, filter size of the convolutional kernel. LR, or known as learning rate, controls the Adam optimizer learning space, where a smaller value ensures gradual learning. Trains the dash test dash split. Propor- Proportion of dataset allocated for training. Num epochs, number of complete passes through the training dataset. Batch
Batch
size,
size.
number of sample processes per training step. Model name, file name for saving the trained model. Key steps in the process. We have three key steps. First is defining classes. The defining classes function scans the training directory, identifies subdirectories as classes, and stores their name in a list. Second is loading the processing data. The create slash train slash data functions loads image using OpenCV, resize image to the specified dimensions, associate each image with its class label, and shuffles data for randomness. Third is data augmentation. expands the training dataset by applying transformations like rotations, flip, and shift to improve model generalization. The data is split into training and testing sets and labeled are one-hot encoded. Building the model, the CNN architecture is defined using layers like convolutional layers for feature extraction, batch normalization to establish and accelerate training, max pooling for downsampling feature maps, dropout to prevent overlifting, and last is flatten and dense layers for classifications. Next is compiling the model. The model is compiled using optimizer, Adam optimizer, and last is loss function, categorical cross entropy. Training the model. The model is trained with augmented data for better generalization metrics such as accuracy and loss are monitored during training. Saving the model, the trained model along with architecture which is saved as a .h5 file class name are also saved, ensuring the model is ready for deployment or further training later. A confirmation message is displayed upon successful saving.
Test interpret.
Test.
Give
Test demonstration. Um, Welcome to test demonstration on testing a machine learning model for image classification using a convolutional neural network or known as CNN. Here's what we'll cover. This dataset presentation on overview of the dataset used to train the model. Second is model training and evaluation, explanation of the training process and performance evaluation. Data overview. The data overview consists of image categorized into two classes stored in the training categories, directories. We have two dogs and cats. It is balanced the data containing 250 dogs image and 250 cats image. Step 1 importing required libraries. As discussed earlier, the first step in any machine learning project is importing necessary libraries. Those libraries provide pre-built function and tools, streaming development and allowing us to focus on the core application logic instead of implementing underlying functionalities from scraps. Second step, hyperparameter and setup for testing. Key parameters for testing includes image size equals to 145, specifies and size specifies the size uh, by 145 by 145 pixels to which all test image are resized. This ensures uniformity for input to the model. Second is image channels. Indicates the number of color channels in the input image. Green, red, and blue. Model name. Animal slash CNN dot
H5.
H5. Specifies the file name of the trained model to be loaded for making predictions. Step 3. Loading the trained model. This involves loading the trained CNN model using TensorFlow load model functions. If the model loads successfully, a confirmation message is displayed. If the loading fails, an error message is printed and script exits gracefully. Step 4. Checking model input shape. The model's expected input dimension are validated to ensure that the test image matches the required shape. This avoids error during prediction. Step 5. Pre-processing the test image. The test image undergoes several processing steps. First is resize to specify dimensions like 145 by 145 pixels. And second is normalize pixel values to fall between 0 and 1. A batch dimension is added to prepare the image for model predictions. Then step 6, making a prediction. The trained model is used to predict the class of the test image CC1 dot GP, GPA, JPJ. The test image is processed and passed through the model. The predicted class is displayed alongside the test image for clear visualization. The dimension walks through testing and trained CNN model for image classification by pre-processing the test image, loading the trained model, validating input dimension.
So now we're gonna show you how to demo our system. So first we're gonna demo the cut CC1 siya to. So we're gonna wait for it to load. Location. There you go. It's predicted as cut and it's in here below. Models loaded successfully. Now we're gonna try the second image of the cat. CC2. Listen, wait, stop na.
Hmm,
Sa,
wait for a while. There.
now we're gonna run the second picture of the cat. Let's see, it's loading, reloading.
Dapat ko ang tingog. More hindi siya
Here we go, the second picture of the cat. And now we're gonna try the picture of the dog. DD1. So here we go, it predicted dog. Now we're gonna try the second pic of the dog. So there you go, predicted is dog. So that's all. Thank you, miss. Bye
Bye.
bye.